Hello, my name is Adolfo Garcia, and I am a software engineer with ChainGuard Inc. We are a company devoted to software supply chain security, and we are on a mission to make all the software in the world secure by default. Today, we are going to be talking a little bit about what an SBOM is, the benefits that you can get by running and consuming, producing SBOMs along with your software releases, and some of the state of the tooling out there, and maybe take a look at what the future holds for us. Okay, so first, a little bit of background. So even though there's been a big push to produce and consume SBOMs in the last few months, we saw that there's still some confusion out there about what an SBOM is, the benefits it can give you, how it overlaps with other technologies. And we wanted to start reaching out and sharing some of our findings and some experience about using and producing SBOMs. So what is an SBOM? This is the official definition from the NTIA.gov website, which basically defines an SBOM as a nested inventory that lists all of the components that go into making a piece of software. So in order to understand this idea a little bit better, let's try to do an analogy. So if you think about whenever you get a box shipment in the mail, say, for example, you order a new computer, you'll notice that it always has a little packing slip attached to the side of it. That packing slip tells you a couple of things about the shipment you just received. So the first one is it'll give you some information about the shipment itself, so some metadata. It'll tell you where the package came from, when it was shipped, if it traversed some checkpoints like international customs or things like that. Then it'll tell you things about the contents. So it'll tell you what you can expect to find inside of the box. It'll tell you what these things look like sometimes. For example, it'll tell you if you have a piece of red clothing or blue clothing. It'll help you figure out if everything that you should find inside of the box is in there, the number of pieces and things like that. And it also help you determine if the things are in good shape. Did that vase that you order get in one piece, or is it supposed to be in multiple pieces? Did it get corrupted in any way? Or maybe if you order an expensive handbag somewhere, you don't want it to get replaced by a cheap knockoff on the way to you, right? Then it'll tell you some other things about the manufacturing process that brought your item to life. So, for example, if you've ever ordered a Dell computer, you notice on the packing slip that it'll list each of the components inside of it. It'll tell you the kind of memory, the CPU that it uses, things like that. And you can use the packing slip to verify that the pieces inside of your computer actually match what is listed in the packing slip. And then it'll tell you some information about the manufacturing run that produces your computer. So, for example, if the manufacturer finds out that there was a batch of bad computers, it may be able to locate your computer, and you can find via the serial number, the lot number, if your computer is faulty in any way. So an SBOM allows you to answer some similar questions about your software. For example, it'll allow you to answer the same as the packing slip. It'll allow you to tell about the origin and the provenance of your shipment. So where did it came from? Can I download this software again? From where, and what can I expect from it? And you can use this kind of information to plug it into the security tools to check dependencies and the base image, the images that you use to run your containers, and it'll allow you to find if they have security vulnerabilities in them. Then you can also gain information by automating the SBOM consumption and generation during your CI runs. You can generate an SBOM when you run it in your CI/CD pipeline, and you can also check SBOMs during your CI/CD runs to check the components that you are actually pulling in. Then it'll help you resolve some licensing questions. So you can check for compliance. For example, if you are pulling dependencies that have like really strict regulations and restrictions that you cannot allow into your project, and SBOM will allow you to figure that out. It will also allow you to find out if you can release your project as open source, for example. Maybe some of the dependencies that you are pulling in restrict you from doing so, and the SBOM will let you know if you can do it or not. Okay, so next up, the two main SBOM standards. There are two competing SBOM standards, both of them really good, and both of them are competing, but in a friendly way, always sharing knowledge and best practices among the projects. The first one is SPDX. It's a project from the Linux Foundation. It has been under development over 10 years now. And the second one is CycloneDX, which is a project of the OWASP Foundation. Today, we're going to be focusing more on the SPDX side of things, which, by the way, is already an international standard. So what is SPDX? SPDX is the standard to write SBOMs, and it's designed to describe software releases in terms of packages and files, which are described in a document. These two elements are related between each other by a rich set of relationships that give semantic meaning to what you find inside of the SBOM. Then once you define your components, you can output the SBOM in a number of different formats like tag value, JSON, RDF, YAML, XML. The current version in use is 2.2.1, and we're expecting version 3.0 to be released really soon. Like I said before, it's an ISO standard already. So let's take a look at what the actual SBOM looks like. Like we said before, the SBOM is a document. So if you start with a clean document, the document itself already has some information about itself listed. So it has an ID and a namespace, which allow it to exist in a unique way in the internet. It has a name, generally the name of the project. It states the SPDX version that has the time of creation, who produced it, the tooling used to it, and so on. So inside of the document, you can start by the blank document and you start adding things to it. The first thing that you may add to it is a package. So you can add a single package and not have anything inside of the package defined. This will allow you to state some things like, for example, the package version, its licensing, the version, and the name, things like that. Or you can also add a package and also list the things inside of the package. A package can group together files and also other packages, and some of the contents have their own metadata listed in there as well. You can also add to the SBOM single files. This can be listed at the top of the document. And like we were saying before, the most important part of the SBOM is its ability to relate all of its elements with several different kinds of relationships. So if you see here, if we can this fictional SBOM lists that package number 1 was generated by the files inside of package number 2, and then file number 3 has a single test, which is the external file number 1. So if you want to take a look at how the SBOM looks like, this is a little bit of a sample of just a snippet of an SBOM, SPDX SBOM. I generated this from the Istio service mesh source code, just to take a look at how it looks like. we'll see during the demo a little bit more about this. So just to recap, the two kinds of elements inside of an SBOM, there's file, which lists all of the file metadata, like its name, the type, the checksums that detail its contents, the license, and some other attributions like the copyright, and you can add notes to it, so on. And then there's packages that group other packages and files, and packages can have a name, a version, a file name, the supplier, so who am I pulling this package from, and the originator. And you can also have a URL of that tells you where you can download it if you want to get it again for checking or things like that, and some licensing information. And finally, there's the relationships. Like said before, SPDX defines over 40 relationship kinds that can give like really semantic richness to the document, and beyond just a simple dependency relationship among them, you can express whole lots of other things. So I've prepared a little demo to demonstrate some of the things that we've been going through here. So let me switch my screen. All of the demos that I'm going to go to do today are done using the Kubernetes SBOM tool, which is freely available. It is a tool that was produced in order to create the SBOMs for Kubernetes. It is a tool that will allow you to create SPDX documents that accurately describe Go projects. So right here, I'm inside of a sample project of mine. This is a little project that I like to use to demonstrate the bill of materials capabilities of BOM. So if you look at it, it's like a fairly standard project that has some Go packages, produces a binary, and it also produces a container image, which is a GitHub action. So while you can run the BOM tool by itself and pass it command line flags to define your BOM, it is really designed to be run inside of a CI/CD system. So it's designed to be run as one of your steps in your pipeline and read from a configuration file that states what it should do. So let's take a look at how the configuration looks like. So let me make it a little bit bigger. So this is the configuration file for the tool. If you see here, it defines some of the aspects for the bill of materials that's going to be produced. It states the namespace, the license I'm using for the project. It also states the name of the SBOM, who created the bill of materials, and the artifacts I want to list in my SBOM. So if you see the artifacts list, I'm listing here four things to be defined in my SBOM. One, a directory, which is the actual source code for the project, which is the current directory. And I'm asking here BOM to analyze the Go modules to fetch all of the dependency information. Then once I run my build, it'll output a binary here, which is called miniprow. And I'm going to add miniprow as a single binary to the SBOM. Then I'm adding the README file as a single file, and I'm also specifying the SBOM tool to add a container image here, which will go and fetch from the registry and describe it in the SBOM. So first, I'm gonna run my build here, and it's going to build the binary and also build and push the container image, which is it's pushing it to the GitHub repository. So if I see, so now that I have my image, I can run my SBOM. So I can go and generate my SBOM by using BOM generate and I'm passing it the configuration file, which is .sbom, and I'm going to write that information to a file called SBOM SPDX. So a couple of things are going to happen here. So first, it'll read the configuration, then parse all of the dependencies of my Go project. Then it'll go and fetch all of the Go modules. Actually, right now it's using them from a local copy. Since I just ran the build, I have local copies of all the modules, and it'll analyze them for their licenses here. And then it'll fetch the container image from the registry and describe each of its layers inside of the BOM of the bill of materials, and then add the single files to the bill of materials. So right now, if I take a look, I have the file generated inside of here, and it's written. So one of the advantages of the BOM tool is that you can use it to see and explore a little bit the document that was just produced, and it'll allow you to draw an outline of the document. So if we see what came out, this is the actual structure of the document I just produced. So my document has two packages, which are first the source code directory here, which lists all of its files. All of the metadata of each of these files is listed in the SBOM, the checksums, licenses, and all of that. And also all of the dependencies. So the main package miniprow has files and packages inside of it. And then at the top level of the document, there's another package which represents the container image. That container image is one tag, and that tag has one SHA inside of it, which corresponds to the AMD64 image I just produced, which has two layers listed in there. And then finally, it describes two files, single files. One is the binary and the README. So this is, as you can see, producing an SBOM is quite an easy task, and you can use it like fairly easy. So this is a demo of the automation that you can do. I wanted to show another feature that you can do. So here, now I've switched tabs and I'm inside of a clone of the Istio service mesh code. Istio is a service mesh for Kubernetes, and it's a Go project. I chose this one because it's a fairly large and complex project, which we can use to demonstrate the following features. So let me first remove the current SBOM, and let's generate one for the current Git clone. So this will take a little bit more because Istio is a fair larger project than the demonstration project I just used. So it's fetching all of the dependencies for Istio, and it's since I haven't built the project, it is now fetching all of the Go modules from its current repositories and listing them in the SBOM. And I have my SBOM now. So if I draw the outline of the SBOM, you'll see that it's a huge SBOM compared to the other one. So this one lists like literally thousands of files and hundreds of dependencies down here. Using the tool, I can define so I can constrain the depth of the visualization to understand it a little better. So I just generated an SBOM document which has this name, which is an automatically generated name because I didn't specify one, and it lists one package called Istio, which is the same name of the current directory I'm in, and it defines 4,000 relationships inside of it. So among dependencies and the source code, we have 4,000 relationships, one-way relationships inside of the SBOM. Now, if I want, for example, to know the licensing information of the package, I can use SBOM to explore a little bit more. So I can do SBOM document license and then pass it the SBOM license. So using the license subcommand, what it allows me to know is, so I have one package, it's SPDX ID, and it tells me that it is licensed under the Apache 2.0 license. That information came because SBOM recognizes as a classifier that learns licenses and recognizes the licenses it finds inside of the source code repository. So this one, as we can see here, is licensed in Apache 2. So it matches this one here, but there's a caveat here. So the package, the Istio package, pulls 215 dependencies. And among them, there's 7 other different licenses. So using the same tool, I can explore the licensing information for the packages. So if I pass it the SBOM and a name of a package, it will print a licensing table describing all of the licenses and what the tool thinks is the most appropriate license for each of the dependencies. So if you want, you can also license. You can also specify other ways to get this. For example, you can get the licensing information in JSON if you want to feed that information to an automated tool further down your pipeline or another process. So I guess that's a little bit, that's features I wanted to demonstrate here. This is the link for the tool is going to be defined at the end of the presentation. So you saw that tool in action, but what is the future? So a nice trend that we're noticing as of a few months back is that some of the tools that release software, that compile software, that produce container images are starting to gain SBOM generating abilities. So if you're familiar with Go Releaser, which is a tool to compile and publish the artifacts of a build to GitHub, it just recently gained the ability to generate an SBOM describing the artifacts that you're releasing. Then there's KO, which is a tool to turn your Go source code into a container, and it also can generate and publish an SBOM describing the container image dependencies to the registry. And then finally, we in the Kubernetes project generated a little tool which is called publish release, which can also publish all of the artifacts of a release and then send the SBOM along with them. So we believe that we believe that this trend is going to be we're going to be seeing this trend more and more among some of the tool makers and software release projects that are out there. And it basically means that more and more you're going to see that whenever you publish a software release, inadvertently you're also going to be generating an SBOM model with it. And some of the current efforts are, like you saw in the licensing demo before this, are starting. So some of the efforts among SBOM tool makers are to really start giving the relationships that semantic meaning that they should have. Like you saw before, when you have a software release that describes its dependencies, we can now read the SBOM, follow the dependency relationship, and then extract the licensing information to provide custom reports that allow you to find out your compliance. So we think this year is going to be the year of the SBOM because you're going to see more maturing of tools like I just showed you, and it's going to be it's a perfect time for you to start generating your SBOM. So with that, I'd like to thank you. Again, my name is Adolfo Garcia Veytia, And you can find me as Puerco almost anywhere, Twitter, GitHub, whatever. And here are links to the original blog post that I gave, what's the origin of this talk, and a link to the Kubernetes BOM tool that I just showed you. And feel free to reach me if you have any questions about the tool or any of the techniques that I just showed on the demos. So that's it then. Thank you.